Okay, now, when you look at this polynomial, it looks scary, right? I'm not going to make you factor that, but I do expect you to be able to figure out what shape it makes. Now, what is the only term that matters when you're looking at the shape? That one right there. Does any of this matter for the shape? No. Nope. Just the first one. So x to the fourth, what shape does that make? There we go. We've got a u. So the degree is 4, the leading coefficient is positive, so it's going to make a u. Now, we do like that -6. What does that tell us? Good job. That's the y-intercept. So the way that this polynomial is written, this is called standard form. Notice there's no parentheses. This is all written out. And when it's in standard form, the degree is the highest exponent. Okay? Now when we get it into factored form or intercept form, that's where we got the parentheses. That's when you have to add up the x's. Okay? So what we learned from this is that first term tells us the shape, last term tells us the y-intercept. This is what this polynomial looks like in factored form. So if we were able to go and factor this thing, now it's going to look like this. Why do we like intercept or factored form? What can we learn when it's in intercept form? The intercepts, right? That's why it's called intercept form. Okay, so let's go to Ambriana. Help me out with this. What are my x-intercepts going to be? What makes those parentheses turn to 0? Yeah, the opposite. So here, what would that mean? Those are your x-intercepts. And then, Jade, what are their multiplicity? So does that mean it's going to bounce or cross at the x-axis? The 1 has a multiplicity of 2, so it, yes. Keep going. Good job. Okay, that's how we do this. Is this anything new? This is just what we were doing earlier, but now it's got more that's going on. So now we're going to combine what we learned from intercept form and standard form, put it together, and graph this equation. Okay? So what we learned earlier was that this is a u with a y-intercept at -6. We learned that the x-intercepts are 1, -2, and 3. And that it's going to bounce at 1, because it has an even multiplicity. And then it's going to cross at the other ones. So now what we're going to do is just put all of that into a graph. What I start with is I start with the intercept. So we know there's going to be an intercept at -2, where it's going to cross. So I'll put a C by it. There's an intercept at 1, where it bounces. And an intercept at 3, where it's going to cross. Don't you like these bigger graphs? Aren't they much better than those little tiny ones? Okay, now, what shape does this make? A U. So I'm going to start at positive infinity and come down and follow along. Also, we've got a y-intercept at -6. Alright, so what we're going to do is start at positive infinity, and we're going to come to our first x-intercept. We're going to cross. So it's just going to come down, cross, and it goes down a while, but then we get through our x-intercept. What happens here? Bounces off, and then it's going to cross up like that. And that is our graph. How would we check our work? Put in decimals, it should match. Okay, but that's a little bit longer of an equation. I'm going to have you check it on your own time, okay? Okay, any questions on that one? Let's do another example. So here's a new one. This time we're going to start in intercept form. So it's already like that. So I want you to take 30 30 seconds, and I want you to try to fill out as much of this as you can. What are the x-intercepts? What's their multiplicity? Will it bounce or cross? Go ahead, get started there. Oh, you're not here when I handed these out. Alright guys, help me out. What is our first root going to be? What turns this parenthesis into 0? 1. Negative 1. And anyone know this one? It is 1/2. Good job. If you don't see that, just set the 2x minus 1 equal to 0. And then we're just going to do some algebra here. We want to solve for x. So what do? Add 1, and then, and there's our x-intercept of 1/2. Okay, so those are our 3 x-intercepts. What is the multiplicity for each of those? Okay, yep, it's going to be 1, 1, 1. They're each used once. And since 1 is odd, what does that mean is happening at the x-axis? Okay. Now, I'm just given that equation here. How would I get this into standard form? That's where it's written out with no parentheses. What would I have to do? I would have to distribute it up. Now, it is a skill that you need to know how to do, so I'm going to show you how to do it on this one. But then I'm going to show you a shortcut method for using it. You do need to know how to multiply it all out, but sometimes it's just easier if you only need to know, if you only do part of it. So, let's go through that. If I were to multiply out x minus 1 with x plus 1 with 2x minus 1, what we're going to do is let's start with the first two, and we're going to lobster claw. So I just have to multiply it all out like that. When I do that, I'm going to get x squared plus x minus x minus 1. Which I'm still going to have to multiply with 2x minus 1. But let's combine our like terms here. X minus x is 0, so those just go away. So then I get x squared minus 1, which then I need to distribute with 2x minus 1. So then we got a lobster claw again. We're sending that x squared to both of these, and then the negative 1 to both of these. When we do, we get 2x to the third minus x squared minus 2x plus 1. Now that actually wasn't too bad, okay? There are times where it could be a lot more work to multiply that all out. But this is when I would ask, is there an easier way to do this? So how do we convert to standard form? You're going to have to multiply it all out. Multiply it all out. But really, guys, when we're doing this, would there be an easier way? If I were to go back and look at one of these examples when it was in standard form. Okay, here's our example where it's in standard form. What are the only terms that matter there? The first and the last. Do we care about any of that when it's in standard form? Not really. So let me show you a little shortcut. Is this where we were? Or was it? Is this where we were? Let me show you a little shortcut for how you can get those, okay? It is supposed to be erasing. What are you doing here? Alright, we'll just have a big red circle. Okay, I'm going to show you a shortcut here. What we're going to do is we're going to get the first term, you're just going to take the first term in each parenthesis and multiply them together. What's 2x times x times x? 2x. That's 2x to the third, which is that what we got when we multiplied it all out? Great. That's how you get the first term. That tells you the shape. How are you going to get the last term? The negative 1 times 1 times negative 1. So just multiply the constants and you get negative 1. Is that what we got here? Wait.
1.
It'd be positive 1. Because it's a negative times a positive times a negative, so it's positive. Did that match what we got before?
Yes.
So now you're going to have questions where you are asked to multiply it all out. But other times, if you're just trying to go a little faster and you don't want to multiply everything out, you can just do what I just did there. That gives you the first term, which gives you the shape, and the last term, which gives you the y-intercept. Now, let's go and graph this thing now that we've got the information that we need. Okay? What were the roots? Well, we already wrote that down on the other page. That was 1, negative 1, and 1/2. They were all used once, so what's going to happen in all of those?
They all come.
Cross. When we multiplied it out, we got 2x cubed. Degree was 3, the leading coefficient is positive. So what shape will that make if 2x cubed is our first term? That's an S curve. Alright, and then what did we say the y-intercept would be?
1.
Positive 1. So if I go on here and graph that. So 1 right here, well, negative 1, positive 1, and then 1/2. It's a little tight there. So I'm going to cross at all of those. We have a y-intercept at positive 1. And we know it's going to make an S curve. So I'm going to start down at negative infinity